Hello, viewers. I welcome all of you to the last part of the preliminary design and development. Let's go through that. Okay. Preliminary design and development, part 3. Let's see what are the learning objectives in today's session. The first learning objective is the DFMEA. Next, we will get to know about the design review and the release. DFMEA. DFMEA stands for Design Failure Mode and Effect Analysis. Maybe most of us know about this. What exactly is the DFMEA? DFMEA is a process of knowing and understanding the potential risks associated with the design. Okay, I hope it is pretty clear from the definition that why DFMEA has to be done. If we want to know the potential risks associated with the design at the early phase, we have to do the DFMEA. Okay, once we get to know these risks earlier itself, we can frame our risk mitigation plan as per the risks associated with the design. Let's deep dive into DFMEA. So this is a typical table which you can find most of the engineers using. Now let's try to understand this table first. So the engineer who wants to do the DFMEA of that particular part or a component enters the name of that part here or the part number, or it could be even the product number as well. Then the date on which the DFMEA is done has to be entered. Next, the name of the engineer or the complete engineering team who does the DFMEA. You can also see that the FMEA table is having several columns. The first column, what we observe here is item. So under this column, we need to enter what is the name of that particular item or a system. If it is a system, then it is a SFMEA. If it is a particular item or a component, then it is a DFMEA or a design FMEA. Okay. Then comes the function of that particular component. What is the intended function of that particular item? Next is the potential failure mode. The potential failure mode is all about how might the function fail. Means what is that mode which causes the failure of that function. Okay, it is not the potential causes. So we should not get confused with the potential causes of the failure and the failure mode. Failure mode is more about the mode of failure only. Okay. Now, for example, if you are sitting inside the house and you experience the leakage from the roof during the rainy season, then the potential failure mode is improper sealing. It is not the leakage of the roof. It is improper sealing. Improper sealing has caused the leakage. Why that improper sealing has happened is the potential causes of the failure. Okay. Then potential effect of the failure. What effect will the failure have on the customer? And how severe that failure is? The scale of the severity depends upon the severity of that particular effect. If the severity causes serious injuries to the person who is using that particular item, then the scale of the severity is almost high, in between 8 to 10. Now, suppose if the severity uh, causes the non-functioning of that particular item, then the severity scale is in between 5 to 7. Now, suppose if the severity causes only disturbance to that operator, then the rating of the severity is in between 0 to 5. Okay. Now, as I told before, the potential causes of the failure. What is the reason because of which the failure happened? Occurrence. Occurrence is how often the failure will occur during the entire tenor or during the lifetime of that particular component. Detection. Detection is how likely the failure will be detected before the failure reaches to the customer. And RPN is the risk priority number, which is a multiplication of the severity, occurrence, and the detection. The risk priority number is calculated for each item and for each potential causes of the failure. Okay, so whichever potential causes of the failure gets the highest rating, that is addressed first. Next is the recommended actions. So the recommended actions is what actions are needed to reduce the severity, occurrence, or the detection. If you want to know more in detail about the DFMEA, please visit this website. Now let's check what is the DFMA that is being done on the fruit auto sorting machine. So let me take you to the chart to explain you about the DFMA. Okay, so this is the DFMA chart that is being done for the fruit auto sorting machine. Now let's take the items one by one. The first item that was identified for the DFMEA is the receiving net. The function of this net is to reduce the falling speed of the fruit by around 50%. Okay. Potential failure modes. What the engineers have identified here is this function will fail because of no reduction of the speed of the fruit. And what is the potential effect of this failure? The potential effect of this failure, what the engineers have identified is that the fruit may bounce out of the divider channel. And the severity of this failure, the rating that is given here is 7 because the falling of the fruit will not injure any operator. Now, moving on to the potential causes of the failure. What could be the potential cause of this particular failure? Okay, why the speed will not get reduced? The engineers have thought that the neck diameter is not enough to cut down the speed. It means that when the fruit falls in the neck, first it will fall in the surface and then it will fall onto the diameter. So it is easily slipping through the diameter. Okay, the probability of occurrence is 8. Now coming to the current test method. Here the engineers think that can we come up or can we develop some setup where we can conduct the trials to check if the failure could occur. So this is very important activity because based upon the result of the trials, the detection number is decided. The detection number says that how likely the failure could be detected in that particular trial period. If it can be detected easily, then the detection number goes less. If it is very difficult to detect the failure, then the detection number goes very high. If I want to tell it in other words, if the detection is very simple, then the number is less. If the detection is complicated, then the number increases. Okay. Next comes the RPN. The RPN is a multiplication of the severity, occurrence, and the detection. So here the RPM number that we have got is the multiplication of 7, 8, and 5. Okay. And the recommended actions for this is choose appropriate diameter. Okay. Now let us see what is the next potential causes of the failure. So engineers observed that there is only one stage of the reduction to reduce the speed of the fruit. Okay. So that is what they have highlighted here. Okay. And the probability of occurrence remains the same. Current test method. To check the speed reduction is very difficult at each stage. So the engineers have identified that there cannot be any uh, test method to check the speed. The engineers can come up with a setup to check the speed, but that technology will be very complicated one. So what they have identified is that currently there is no test method to check the speed at each stage. So that's the reason the detection number goes very high. Okay, and the RPN for this also goes high, and the recommended action is include more than one stage of the speed reduction. Now let's go to the next item, that is the oscillating gate mechanism. The function of this mechanism is to move the gate from the right to left or vice versa in 2 seconds. The potential failure mode for this particular function is delay to complete the travel. What are the potential effects of the failure? The fruit might be diverted on the wrong side. Imagine that the gate is in the middle of the divider, and if the fruit comes and hit the gate which is at the middle portion of the divider, then the fruit might either go towards the left side or the right side. Okay, so the here the risk is that the wrong fruit going to that particular bin. If the fruit is okay and if it goes to the non okay bin, then it will be a problem. Okay, what is the potential effects of this particular failure? The fruit may be diverted on the wrong side. That is what I was telling. The next, the severity of the failure. The severity of failure is less because this will also not injure any operator. Now coming to the potential causes of the failure, the delay to travel might be because of the dust on the divider. Okay, current test method, what the engineers have come up with, the checkpoint here is to clean the surface roughness and to carry out the multiple trials if the failure occurs again. Okay, so this is something which can be detected very easily. Okay, so that's the rating of the detection goes down, and also the RPN number also goes down here. Okay, and the recommended action is to provide the clearance between the gate and the channel. So in all these three cases, here what we observe here is that the RPN number is high for that potential cause which is identified as only one stage of the speed reduction. Okay, so the recommended action here is to include more than one stage of the speed reduction. Okay, so this action has to be addressed first among all these because the RPN number is high. Now swapping to the PPT here. Okay, here you can observe the picture of the net of the concept design and development data. The second picture is of the preliminary design and development data. So after carrying out certain trials, the engineers decided to keep the first stage diameter as the same. And the second stage diameter, they have reduced it to half of the first stage diameter, that is 75 mm. And the second course of action is taken on the gate. So if I take a section through the gate and the divider, you can observe here that the distance of 7 mm is maintained as a clearance between the gate and the divider. So this is all the results of the DFME. If this was not carried out, this would have uh, affected the functionality very badly. Okay, moving on. Let's see what is the next step in the preliminary design and development process. The next step is the release process. And generally, the release process happens in the PDM. What is PDM? PDM is a product database management. PDM captures the previous versions of the developed technical solution of that particular design and also the in-work version of that particular design. Once the previous version of the design gets released, then it is shown as a valid state in the PDM. Okay, that version is over. Then the engineers go for the next revision of that particular system or assembly and they release once the job is completed. So all those versions are captured in the PDM. Okay, and the PDM also captures where that particular item is going and in which particular assembly and in that which particular vehicle. Okay, and it also captures the bill of materials of that particular assembly, which PLM cannot do it. Maybe I can take another session to explain you the difference between the PDM and the PLM. Okay. So before we go to the release process, let's try to understand what are the different maturity levels of a component or assembly in a particular design phase. So I can also call it as a release stages or even the maturity levels for that particular component within the design phase. So if the engineer takes the new version of any component, it will be shown as a initiated in your PLM software. That is a product lifecycle management software. Okay. And the number is assigned to that. And once the engineer starts working on it, he promotes it to in work from the initiated the stage. Okay. The difference between the initiated to in work is that in the in work, any engineer can either lock it or unlock it. Means the control of the development remains only with him. If it is in the initiated stage, anybody can do anything. Okay. The next stage is in review. The in review happens once the designer completes all the work of the development and he freezes the design in the PDM. Yes, I will explain you what it is. Okay. Once the engineer freezes that particular technical solution, it goes for in review. Okay. Once the reviewer approves the technical solution, then that complete revision of the design and development goes to invalid. Now let's see in detail what the release process is. Okay. The first step in the release process starts with the engineering change notice. The engineering change notice is a particular number or a basket where that particular set of revisions of that particular design phase is stored. Okay. So that basket is labeled with a particular number called as ECN number. The next step is the assignment of the part and the document numbers to those set of components or the assemblies in that particular design phase. Okay. So these numbers are created from the PDM and then it is assigned to the PLM. Once the numbers are created, those have to be registered under that particular engineering change notice number. Okay. And parallelly, he also includes the reviewer's name in the reviewer's log. Okay, what is this reviewer's log? The reviewer's log contains the set of the names of those particular reviewers who will review your design and further approve them to proceed for the proto release or for the concept release. Okay. The next step that is involved here is the generation of the BOM, where the engineer manually generates the BOM of that particular assembly. Or if there are only two components, then this step is excluded. Okay. The next step here is creation of the proto or the RFQ drawings. The engineers create the drawings of the components only, and that too the requirement of those drawings is only for the RFQ or the proto release. So he gives only the basic dimensions for those views. The next is design and documentation review. So to do this, the engineer has to trigger this review. The triggering is done by pressing the freeze button in the PDM software. The PDM software, if I had that PDM software in front of me, I could have shown you that. Okay, so there is a particular button called as a freeze button in the PDM software where the engineer presses that button and it triggers for the review. Once the engineer presses the button, he cannot do any design modifications on this particular design. Okay. The next step is the review, where the developed solution is subjected to the cross-functional review. So all your documents, materials, attributes of the components Everything, I mean the weight, everything, etc., is subjected to the review. So generally, friends, there are two documents associated with any component. One is the design specification document, which shows the details about the weight, overall dimensions, and the material standards. And another document is your drawing document. And in case of the assembly, it has two documents. One is the bill of materials and the assembly drawing. All these documents, along with your CAD data, is subjected for the review. Okay, if the cross-functional team says that, okay, boss, whatever you have done is okay, and we are approving your technical solution for the development, whatever you have done, then it goes for the design release. So this design release is mainly done for RFQ. RFQ stands for request for quotation, prototyping release. And the data is also released to check the manufacturing feasibility at the supplier end. So these valid documents is distributed to the cross-functional team. Mainly, the purchasing team picks up this document and distribute them to their potential suppliers. So, in the advanced version of the product design and development process, I will also explain you what will be the roles and responsibilities of the cross-functional team in the entire product design and development process. Okay. Now, if the reviewers find that it is not okay, then it is subjected to the correction of the design and documentation according to the review feedback. And it is again looped back to the correction activity. So once the correction activity is done, then the engineers freeze it again. Okay. So this is all about the release process in the preliminary design and development process. And the same thing also continues even in the detailed design and development. So generally, the release process is applicable from the preliminary design and development phase onwards. So before that, they may do the internal release, but not to the cross-functional team. Of course, the concept data is reviewed in front of the cross-functional team, but it is not released because there are two concepts which get generated in the concept phase. And to release both the concepts will be the waste of time, and it will be the unnecessary creation of the numbers, which is of no use. So that's the reason the product team thinks that let us release only the frozen design or the frozen concept to the next level of the product design and development phase. Thank you, viewers, for watching the entire session on the preliminary design and development. So, if you have any doubts or questions, please message me in the message box. Take care. See you soon.